All right, Algebra 3, Lesson 37. If you open to page 262, it's telling you, it kind of breaks down into two things. They have this split as to what they call the line as a locus and the midpoint formula. The midpoint formula is pretty easy, but this next part, or this first part, this line as a locus, what they're asking about is we want to be able to find a line that is the same distance away from 2 points. Okay? So, and then we want it in the slope-intercept form of that equation. So there's really two ways to look at this. One of the things that you ought to know, that you ought to write down, whenever we're talking about equidistance, that line that we're drawing is a perpendicular bisector between those 2 points. Okay, so if I think of the term perpendicular and bisector, I ought to be able to divide that into 2 equations. Okay, one, perpendicular. All right, so if I'm looking at this first one, I've got negative 14,1 and negative 4,7, right? Okay, negative 14,1, and what was the other one? Negative 4,7. So we're talking about, I want something that's perpendicular to the line that connects those 2 points. Okay, that means that first I have to find the slope, right? So in order to find the slope between 2 points, we use our slope formula, which is y2 minus y1 over x2 minus x1. Okay, that's going to give me 7 minus 1 over negative 4 minus negative 14, correct? Okay, we could agree to that? Okay. All right, 7 minus 1 is, oh, I'm sorry, 7 minus 1. I'm so used to having to think backwards on negative numbers. All right, and negative 4 minus negative 14, 10, good. Okay, so we get 6/10 or 3/5. Okay, but that's the slope between those 2 points. Remember, our phrase was perpendicular. So what do I have to do to that slope? Reciprocal? Opposite, right? Opposite reciprocal. So we would use the slope negative 5/3. Okay? All right? The next thing that we would want is the bisector portion of it, right? Where does this actually occur? Okay? So we still have these coordinates. What do I mean by bisector? What's another word for, in this case? So we're looking at the point that is in the middle between those 2 points. The midpoint, right? Which gets into our formula that we're going to be working out here later anyway. So the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, let's drag this down here a little bit. Okay? All right, so let's see, we're going to have to, okay, so we got negative 14 plus negative 4, right? Okay? Negative 14 plus negative 4 divided by 2. And, well, let's see, 1 plus 7, right? 1 plus 7 divided by 2. Okay? So negative 14 plus negative 4 is negative 18. Negative 18 divided by 2. Negative 9, okay? All right, we got negative 9. And 1 plus 7 is 8. 8 divided by 2 is 4. Now, I'm not quite done yet. I needed this based upon this slope. All right, so yeah, I can use that equation, the equation that he's talking about. We can actually have 2 options at this point. We can do y minus y1 equals m times x minus x1, or we can do y equals mx plus b and solve for b. Which would we rather? The top one. Okay, good. We're familiar with it. Okay. So we start off with y minus what? 4 equals m. What was my slope that we're using? Negative 5/3. X minus negative 9. Okay. So we can go ahead and make those positives. We have y minus 4 equals negative 5/3 x. what would be negative 45 thirds? 45 divided by 3 is what, 15?
Yeah, negative 15.
Negative 15 plus 4. So y equals negative 5 thirds x minus 11. Let's see. Hopefully. We'll double check. And that's the answer. Okay. I can show you a different way. You may not like it, but I can show you a different way. Okay? I think it's shorter than all of this. Okay? All right. So, but everything that we used in here, you've used before, right? So, if you were to forget what I'm going to show you next, could we fall back on things that we know? If I can think an equidistant line between 2 points is a perpendicular bisector, then I know what perpendicular means, I know what a bisector is, and then after I've got those two parts, I can draw the equation of the line, right? Okay, let's do something new. Okay, all right. Equidistant. So it's something that is the same distance from these 2 points. So distance tells me that there must be a way that I can use the distance formula. Okay? And I'm going to show you how to use the distance formula. So we have negative 14 and 1. We have negative 4 and 7. So I'm going to take the distance formula and I'm going to set it equal to the distance formula. Okay? So over here, this is my x, right? So I'm going to get x, I'm going to make minus negative 14 squared, or x plus 14 squared, plus y minus 1 squared. Okay? Over here, x minus negative 4 squared, or plus y minus 7 squared. You with me so far? Okay. All right. Now, I have to FOIL these different sections. Okay? So, this is x squared. Let's see, plus 28x plus whatever 14 times 14 is, which is 196. Plus y squared. Let's see, would be what? Minus 2y plus 1. So all of that makes sense. Okay? Equals x squared plus 8x plus 16. Okay? And then plus y squared minus 14y plus 49. Okay, now that I have two equations that are equal to each other, you're absolutely right. We're going to solve for y. The square roots cancel out. Because it's the square root equals the square root, they're going to cancel. Okay, so that's why I quit drawing them. But I want you to see that it's the distance formula equal to the distance formula so that you understand equidistance. Okay? Because in order to get rid of the square roots, I would square both sides. Right? And that would get rid of both square roots. All right. So what you're going to see, this will happen every time. X's cancel. Y squareds cancel. Okay? Now we're trying to get the y over here and everything else to the right. Okay? So now some of these things I can combine. For instance, 196 and 1 is 197. I'm going to subtract it across. Okay? Let's see. I need to subtract 28x. But I'm going to leave that negative 2y. Okay? So, yeah, I'm going to add 14y over here. Okay? All right? So, let's see. So, we've got 8x minus 28x. And we've got 16 plus 49, right, plus 197. So I got to find out what all of that's going to be. It is minus 197, you're right. Because it's positive 197 over here, I've got to subtract it. So So I have negative 2y plus 14y. That's going to give me 12y, right?
Yeah.
Equals. All right. I've got 8x minus 28x. That's going to give me negative 20x, right? Okay. Now I've got 16 plus 49 minus 197. Negative 132. Now I'm going to divide everything by 12. Negative 5/3 x minus 11. Yeah, and it should be the same thing, right? Because we use the same coordinates. That's why I use the same coordinates so that you can see that if I do the perpendicular bisector method where I'm finding the slopes, getting the opposite reciprocal slope, finding the midpoint, right, then plugging the coordinates of the midpoint back into my point slope formula, I'm getting the same thing as whenever I solve the distance formula, set it equal to the distance formula, and solve for y. Does that make sense? Okay. You guys want to try one on your own? I think that's probably going to be the best thing for you. Want? I'll leave this here. Let's see. You guys solve. No. Solve number 2, and number 2 would be good because it's not a multiple choice. Okay, so I'll hit pause on the video. Let you guys solve number 2. Now, I don't care which way that you solve. You can solve the perpendicular bisector or you can solve the distance formula way. So, the answer that we should have gotten on number 2, we'll go back and, what do I do with my little marker here? Should have been y equals 2/3 x minus 2. If you're working out number 3, I know some of you are, our answer there should be D, y equals negative 5/3 x plus 22, so you might want to practice with that. Some of you have already done that, which is great. Number 4 and number 5 are midpoint formula, just so that we're clear, because I don't want to spend a lot of time there. I think most people know it. Just real quick, what is the midpoint formula? Ooh, x1 plus x2, okay. Over 2, right? You would think that everybody knows these, and you probably even do know them, but I'll tell you that people would get this mixed up with this, okay? They're different things. This is slope formula, this is midpoint formula, but we're seeing the relationship of x1 plus x2, x2 minus x1. You know, we're seeing things that look kind of similar on paper or make us think about different things. You want to know that this is the midpoint formula. So let's do at least one in here. Okay, let's do number 4 just real quick. Just as a question, right? Does it matter which one is x1 or x2? No, but once I pick an x1 and an x2, does it matter y1, y2?
Yes.
Yeah, it does matter, okay? Because the midpoint between 2 points, that's like saying, where is halfway between here and Kirksville? And then somebody else says, well, where's halfway between Kirksville and Milan? Right? It should be the same point. Doesn't matter where you're starting from or you know where the beginning point is and where the end point is. They're both end points, so the midpoint is the midpoint no matter which one. Okay? The only other thing I need you to make sure that you know is in a list of coordinates that this is x and this is y. You wouldn't believe how many students still struggle to understand that this is my x, this is an x, this is a y, this is a y. Huh? You will eventually get midpoint questions on a test. Isn't that exciting? Woo woo! Yeah. You know what's really embarrassing though? Is when people miss them. All right, so real quick, go ahead and solve number 4. I'll walk around and get those answers from you. Hold on, I don't even have it worked out on my paper. Oh, now I have to solve it. No, I've got it here. Never mind. All right, let's take a look. Just the midpoint on number 4. Perfect. Got it. Back here? Not yet. Oh gosh, it takes a long time. I know, it's a lot of hard work. Okay, good. 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 All right. Do you have it? Awesome. All right. Not really concerned with doing number 5. I think everybody's got this. You got it? It is 8, -6. And with that, all right. You guys have your homework assignment, but I want to be trying to be a little bit more accommodating to you. If you guys have a question from your homework as you've looked through it that you want to work with the class, you want me to work it out with you, you take any question from your homework and I'll work it out with you in front of the class on the board. Yeah, make sure it's definitely been assigned. Okay. You want number 8? You better feel that out with the class. Number 8.
3/7 of the way from -2.
Okay. All right. So formula. This is number 8, lesson 37. All right. We have a formula for it, right? What is it? It's initial plus change times final minus initial. Isn't that right? Do I have that formula right?
For sure.
Pretty sure. All right. What's my initial number on number 8?
-2 and 2/5.
Okay. So now that you know this, though, you know that this is the formula. Is this still a question that you want to work out with the class? No. Okay. I just needed to remember the formula then. All right. Perfect. Pick a different one. 5.
Did you read it? Oh, yes. 5.
Number 5. Okay. Number 5. That's what I thought. I was like, those questions for number 8 look really complicated until you have the formula like, oh, okay. All right, number 5. Number 5, the first leg of a trip was only k miles, and Donnie drove at m miles per hour. He miscalculated and arrived 2 hours late. If the time allotted for the second leg of the trip was the same and the second leg was 10 miles longer, how fast did Donnie have to drive on the second leg to get there on time? I love reading them really fast because it makes them sound more complicated, right? It's dirt. Distance equals what? Rate equals what? Nope. Look, we're manipulating the first equation. Distance over time. Time equals what? Go back here. Distance over rate. You always go from the first equation, right, and just solve for the other variables. So distance, rate, time. Okay, now we're going to go back to our reading. Okay. The first leg of the trip was k miles. Right? So distance is k. Donnie drove at m miles per hour. Okay, rate. Okay. He miscalculated and arrived 2 hours late. His time is k over m plus 2. Because more time, 2 hours late, we're adding 2 hours. Okay? All right. If the time allotted for the second leg of the trip was the same, okay, same time, okay, and the second leg was 10 miles longer, how fast? Okay, that should be a big indicator. How fast? So I'm solving for rate. Rate is, so my new rate equals new distance over new time. So that's where I start from. Okay? Now, what did they just say about this distance? 10 miles. Yeah, distance doesn't get faster. Okay? K plus 10. Okay? Because we're adding to our distance. And, okay, was the same. The second leg was 10 miles longer. How fast did Donnie have to drive on the second leg to get there on time? Because he's given the same amount of time, right? K over m minus 2. And I'm going to put minus 2 over 1 because I'm looking at this and saying to myself, I can simplify that, right? So I need to do what with 2 over 1? Same denominator, which is m, so m over m. All right, so I'm getting, let's see, k plus 10 over 1 divided by k minus 2m divided by m, right?
Yeah.
Multiply by reciprocal, because I'm taking a fraction dividing by a fraction. Okay, so I am getting km
K M
plus
plus
10m
M
over,
K minus 2 M.
okay, and it's rate, so it should be miles per hour. Let's check and see if our answer is correct. I'm using the handy dandy cheat sheet. All right, this is what, lesson 37, number 5. I don't know, Arnold. All right, 37, number 5. All right, they've got a little bit different. They've got mk plus 10m. It's the same thing. K minus 2m miles per hour. We were right. Give yourselves a pat on the round of applause. Okay. All right, we're going to hit stop there. You guys got the rest on your own. Oh.